So we have the trig functions. So now we want to learn what are the inverse trig functions. Before that, recall we have a theorem says if you have an inverse function, recall the inverse function exists if and only if this function is one-to-one function. Okay, so now let's look at the inverse of sine. So we know that the sine function is given by this kind of curve, right? It's not one-to-one, because if you draw a horizontal line, you will intersect the curve at infinitely many points, right? It's not one-to-one. However, if we restrict our y equals sine x on the interval from negative pi over 2 to pi over 2. So here is pi over 2. Here is negative pi over 2. Then this part, this curve, if we restrict our sine x from negative pi to pi over 2 to pi over 2, so this curve is one-to-one. Then y equals sine x is one-to-one on the interval from negative pi over 2 to pi over 2. So we can define the inverse function, okay, for this part, for the sine x when x is between negative pi over 2 to pi over 2. So the sine function, the inverse of sine function is defined by what? By this form, y equals arc sine x. Okay, or we can write the as or y equals sine inverse of x. So here this negative 1 is not the power, it represents the inverse, okay, inverse function. So now let's look at the graph. So we know that the inverse function, the graph of inverse function is symmetric with respect to the y equals x line, right, with the original function. So we can draw the graph. So this is the, let's look at, this is a 1, and here is pi over 2, here is negative pi over 2. So the original function is given by this curve, right? This is negative 1, this curve. The original function is given by this curve. I should draw more clearly. Okay, so it's symmetric with respect to the y equals x line. So this is the y equals x line. And this is y equals x line, so our graph for the inverse function is this part. Okay, is this part. And this point is pi over 2 to 1, and this point is 1 and pi over 2 here. And we have this one, this point. This point is on the curve is negative pi over 2 and negative 1. So we have this point which is negative 1, 2, and this is the negative pi over 2. So this is our curve for the y equals arc sine of sine inverse. And this is the curve for, this one is the curve for y equals sine x on the interval from negative pi over 2 to pi over 2, right? So from this curve, from the inverse function, okay, from the graph of inverse function, y equals arc sine x, the domain is, first thing, domain is from negative 1 to 1, right? Which is the range of sine function, right? The domain of the inverse is the range of the original function. So here, negative 1 to 1 is the range for the sine x. And the range is the y values, right? Which is from negative pi over 2 to pi over 2. So this is the negative pi over 2 to pi, so which is actually the restricted domain for the sine function, right? So the range of the inverse function equals the domain of the original function. Okay, so here is the one thing that, let's look at the remark for the y equals arc sine x, right? The first thing is this y is an angle. In other words, the inverse trig function is an angle. It represents an angle, okay? 2, y equals arc sine x, it means sine of y should be equal to x. Okay, sine y should be equal to x because y is an angle whose sine value equals x. The third one, and this y is the range, right? Represent range, which is from negative pi over 2 to pi over 2. So this is the fourth and the first quadrant, right? The fourth and the first quadrant. So in other words, this y, if in the xy coordinates, so the terminal side would be in the fourth quadrant or the first quadrant, right? Which is from negative pi over 2 to pi over 2. And this x, this input, is always between negative 1 to 1, right? If you have greater than 1, it's undefined. So now let's look at this example. What is the arc sine of 3 over 2? So since 3 over 2, which is greater than 1, so that means this one is undefined. does not exist. We cannot have an angle whose sine value equals 3 over 2, right? Because the sine value is always between -1 to 1. So this is undefined. Let's look at the arc sine -1/2. Okay, so in order to get this one, we can let y to be arc sine -1/2. It means, and this y must between -pi/2 to pi/2. Keep in mind. It means sine y should be equal to -1/2. Okay, on the interval from -pi/2 to pi/2. So there is only one choice then on this interval to make the sine value to be -1/2. We know 1/2 means that if the angle is pi/6 or 30 degrees, right, then the sine value would be +1/2. But we know that this y should be in the first and the fourth quadrant. So in the first quadrant, it's always been positive. So now it's in the fourth quadrant, right? But it's from -pi/2 to 0. This is the fourth quadrant. So this y must be -pi/6. So we can say that arc sine of -1/2 equals -pi/6. Okay, so this is the quadrant, right? If the angle is from, so it should be from -pi/2 to pi/2, right? The terminal side is on the first quadrant, it's always be positive. So there is only one choice, which is on the fourth quadrant. So this angle should be -pi/6, right, to get the -1/2. Okay, so another example. Sine inverse of √3/2. So we still the same thing. We let y to be sine inverse of √3/2. Then sine y is equal to √3/2 on the interval from -pi/2 to pi/2. Right? So there is only one choice, y equals pi/3. So this is the sine inverse √3/2, which is equal to pi/3. So far, if you're not familiar with that, you just better to still keep these steps. Otherwise, later, when you are very familiar with this calculation, you can get your answer directly. So now let's look at the inverse cosine function. Inverse cosine function. Okay, we know the cosine function is this one, right? It's not 1-to-1. But if we restrict y equals cosine x on the interval from 0 to pi, which is this one, okay, then this is pi. Then y equals cosine x is 1-to-1 function on the interval from 0 to pi. So the inverse exists for this green curve, right? So the inverse function, inverse of cosine is defined by the following way: y equals arc cosine x, or you can write it as y equals cosine inverse of x. Okay, so now let's look at the graph of cosine, arc cosine. Y equals arc cosine x. So the first thing we can draw is, this is the pi over 2, and here is pi. Here is pi, right? So here is 1, and here is -1. -1. So the curve will look like this one. So we draw the cosine curve first. Okay, so this is the cosine function, y equals cosine on the interval from 0 to pi. Then we have a x equals y line, right? Then we have some graphs. Okay, so it's symmetric. So this point, this is the 1, 0 point. So you have the 0, 1 point, or 1, 0, 1 point. So we have the 1, 0 point, right? 1, 0 point. So this is 1 is here, and this point pi over 2 and the 0 point becomes 0 pi over 2. And this one. And this is the pi -1, then we have the pi -1, then we have what? We have -1. -1 is here. -1 and the pi point. Right? Pi point. So that means, so the curve will look like, okay? So if you extend this y-axis, this is corresponding to pi. And here is -1, right? So from this graph, so I just redraw the graph, okay, to make them more clear. So the graph will look like this one. So here is pi. Here is pi over 2. Here is 0. Here is so here is +1. And here is -1. So this is the arc y equals arc cosine x. Okay. Arc cosine. So from this graph, our domain is what? The domain is from -1 to 1, which is the range of the cosine function. This cosine function, we know it's from -1 to 1, right? Our range should be the domain of the cosine. So our restriction domain, restricted domain, which is 0 pi. So here 0 pi is our range, right? Okay, so now let's look at the remark. y equals arc cosine x or cosine inverse of x. The first thing, like we did for the arc sine, and this arc cosine y is an angle. Keep in mind, it is an angle. And 2, this y should be between 0 and pi. So in other words, in the xy coordinate, it should be the terminal side would be in the first and the second quadrant. So here is the first and the second quadrant from 0 to pi. Okay, so this is 0, this is pi. Okay. And our x is input is always from -1 to 1. So the domain is always -1 to 1. Third, y equals arc cosine x. It means cosine of this angle y should be equal to x. Okay, so now let's look at this example. The arc cosine 3/2. Again, 3/2 is greater than 1, so it's undefined. In other words, does not exist. Let's look at this example, arc cosine √2/2. So that means if this is represent an angle, right? If you take the cosine value of this angle, it should be √2/2. So obviously it should be equal. If you are familiar with that, you can get your answer directly. It's equal to pi/4. Okay. So, but if so far we should be very patient to write down all the details, right? Arc cosine √2/2 equals y with that. So that means cosine y is equal to √2/2 on the interval from 0 to pi. Then y must be equal to pi/4. There's only one choice. So we have arc cosine √2/2 is equal to pi/4. So now let's look at the inverse of tangent function. Okay. So we know that the tangent is given by this one. We have the vertical asymptote. Right. So it's not 1-to-1 because if you draw a horizontal line, it intersects at infinitely many points, right? So it's not 1-to-1. But again, we need to restrict our y equals tangent x on the -pi/2 to pi/2. So this is pi/2, and here -pi/2. Then it becomes 1-to-1 because the curve is this part. So in other words, we will restrict our domain on the principal cycle. Right, this is the 1-to-1 function. Then you have what? You have the inverse function, right? So the inverse function is this one. The inverse tangent function is defined by y equals arc tangent x, or y equals tangent inverse x. Okay, so let's look at the graph of y equals arc tangent x. So the graph, so in order to draw the graph of arctangent, we need to draw the graph for the tangent. So we're only interested in the principal cycle, because on this cycle it is 1 to 1. So the graph will looks like this one, right? Okay, so this is pi over 2, and this is negative pi over 2. Then we have a line which is, sorry, I didn't do very well. Okay, then we have a line which is x equals y line. Right, so the graph should be symmetric with respect to this line. So it becomes this one, right? And we have the horizontal asymptote. So the vertical asymptote becomes the horizontal asymptote, which is from, this is the pi over 2, and this is negative pi over 2. Right, so this is the graph for the arctangent. So we can draw the graph separately to make it more clear. This is the graph. This is the pi over 2, horizontal asymptote. This is the negative pi over 2, right? So the graph will look like this one. Right, so this is the graph. So from the graph, we can see that the domain is the range of the tangent. Tangent range is from negative infinity to infinity. So from the graph, it's also from negative infinity to infinity. And the range is the domain. We restrict our domain from negative pi over 2 to pi over 2 for the tangent. So the range would be of the arctangent would be negative pi over 2 to pi over 2. And these two numbers cannot be included because they are the horizontal asymptote. Okay, so now let's look at the remark. Again, y equals arc tangent x, and the first thing, this y is an angle. Right. The second thing is, this is angle. What kind of angle? If you take the tangent value of this y should be equal to the x. The third one, this y is an angle which is angle between negative pi over 2 to pi over 2. So this is the fourth and the first quadrant. So the terminal side should be lying in the first or the fourth quadrant. And here, the input for the arctangent, this x, could be any real number. So now let's look at this one. Okay. Tangent inverse of -1. And we know if we let, that means if you take this angle, the tangent of this angle should be equal to -1. So what is this angle? This is represent an angle, right? So we let y equals tangent inverse of -1. So that means tangent of y is equal to -1 on the domain from -pi/2 to pi/2, right? So what is y? There is only one choice, which is -pi/4. Right, -pi/4. We have no other choice. So this is the arctangent of square root 3. Arctangent of square, so this is greater than 1, but it doesn't matter, right? Square 3 greater than 1 doesn't matter because our input here could be from -infinity to infinity, not like the arcsine and the arccosine. We have to input a number which is between -1 and 1. Okay, so we still can let y equals arctangent square root 3. So that means this tangent y should be equal to square 3 on the interval from -pi/2 to pi/2. Sorry, I should use the parentheses because tangent at the end point are undefined, right? So what are these angles? This angle should be pi/3, right? So arctangent of square root 3 should be equal to pi/3.